Good morning and welcome to AP Statistics. First off, today there's not going to be any live meet. I'm going to be occupied during the time frame of our class, so please watch the video for today's explanation. First, again, the homework, which I believe everybody got right who submitted it. It was on page 133, numbers 70 through 74. The letters were C, B, B, A, D. Again, I think everyone got that right. If you want any review for what's going on so far in Chapter 2, my recommendation is you watch the videos I posted for the days on October 14, 15, and 16. I think that would be a pretty good review because it's everything we've done thus far. What we're going to do today is talk a little bit about how we find a z-score if we know the area behind the value we're looking for. So here's an example of when that becomes necessary. We already know how to find the area if you know the z-score. We have the z-score table, and we also have the normal CDF function on the calculator. I also believe we talked about how to go backwards using the table. If we want to find the z-score that corresponds to a certain area, like the 90th percentile, we look at the z table and we backtrack to try to find what that z-score was. There is obviously a calculator function that will clearly help us, but let's take the example and work from there. All right, so let us say you're told to find a score, which is the x, which is at the 90th percentile. Again, that means that 90% of the population is below this score we're looking for. So find a score x which is at the 90th percentile if the mean of the population, or the distribution in any case, is 82 and the standard deviation is 3.5. So we're looking for a score. Consider this like there's a test that's been given, and we want to find out who's at the 90th percentile. So what score would denote the 90th percentile? So again, if we're looking at a curve, the 90th percentile is over here because it's got 90% of the area above it, below it. Why did I just shade above? There was no need for that. It's got 90% of the area below it, and therefore also 10% above it. So the 90th percentile, basically we're looking for the z-score that corresponds to all that area. Why do I want the z-score? That's the first question. How do we find a value x such that 90% of the population lies below it? Well, remember the z-score formula. Z equals x minus mu over sigma. So if I can find the z-score that corresponds to the 90th percentile, and I know mu, which is 82 in this case, and sigma is 3.5, I'm only missing one variable, which is x, just like algebra. We're trying to solve for x. All right, well, there's two ways that we're going to be able to find that value. Now, the first is using the table. So like I said, why don't you take a second, look through table A right now to find the 90th percentile, the z-score that most closely corresponds to the 90th percentile. Pause the video, find it, and turn it back on when you're ready. So hopefully you looked at the table and you saw that there were a couple of scores that kind of danced around the 0.9, but the closest was 0.8997. Now, it's not exactly the 90th percentile, but it's as close as we can come using the table. It's the 89.97th percentile, which is pretty darn close. It's only 3/10,000ths away. The z-score we found was 1.28. So now that we've used the table, we could find out that the z-score is 1.28. That most closely corresponds to the 90th percentile. So 1.28 equals x minus 82 over 3.5. How do we solve this algebraically? Well, you multiply by 3.5 to clear the fraction, and then we're going to add the 82. So what you get when you do that is 86.48. Okay, so x equals 86.48. So a score on the test of 86.48 falls at the 90th percentile, or at least the 89.97th percentile. So if you can't get fractional scores on a test, let's just presume you can't, and you only get integer scores, what score is going to put us at the 90th percentile? Well, 86.48. How do you want to round that? If you round it down or off, after all, the decimal point is 0.48, so it's less than 0.5. You'd say an 86 places you at the 90th percentile, but understand again, the question is, as it stands, does the 86 really put you at the 90th percentile? Or is it a little bit too low? I think in order to actually stand out and be in the 90th percentile, you have to call that 87. So if you have to round it, we would have to round it up to 87, because an 86 really wouldn't put you at the upper echelon. You wouldn't be at the 90th percentile, the top 10% of test takers, with only an 86. Okay, so clearly there is at least one calculator shortcut that's going to help us right now. And I'm going to show you what that is. So the function I'm going to show you now is right below where normal CDF is. So they try to arrange it nice and logically in the calculator. The function is inverse norm. So in order to find it, go to second, and then vars, and you'll see that the third choice down, at least on my calculator, is invnorm. Inverse norm. It is just what it says it is. Since normal CDF finds you the area if you tell it the z-score, inverse normal will tell you the z-score if you tell it the area. So here's what we're going to do here, okay? There's two things we're going to do. First, just go make sure everything's cleared out and good. The first thing it asks you is, what is the area? Now, you're going to give it the area below the mark we're looking for. So it's the 90th percentile, so it's 0.9. If I ask for the upper 10%, it's still going to be 0.9 because it wants to know, we'll keep it nice and neat. We'll keep it straightforward right now. Let's just presume we're always going to go from the left. Some of the newer calculators, mine included, gives you a tail choice of left, center, right. It gets to be kind of confusing if you mess with that. So just keep it straight in your head, all right? Let's just always presume we're looking at the left tail. So 0.9. Don't say 90, because that's not a value that makes any sense here. Area is out of 1. 90 wouldn't make sense. So 0.9. What is our mean and our deviation? Let's just stick with 0 and 1. We want to find a z-score, and that means the center is 0 and the deviation is 1. Left tail, paste enter, and look, it's 1.281551567. 1.28 was pretty close. So 1.2816 would be a better, more accurate z-score for this problem. And if you plugged in 1.2816 over here, you still get an answer of 86.48. All right, so it saves you, well, it saves you the trouble of using the table, but it also gives you a more accurate value. But wait, there's more. Clearly, we could just bypass the whole thing and use inverse norm with the raw data. Go back to inverse norm, second vars 3, area still 0.9, but instead of using 0 and 1, let's use the actual data we were given. We were told the mean was 82 and that the standard deviation was 3.5. So now it's this is what it looks like, right? You're still looking for the 90th percentile, but now you're using the raw data values for mean and standard deviation. What do you think it's going to tell you if you paste that and enter it? Hey, look. The answer, 86.4854. It gives you the X value. It gives you the raw data value that's at the 90th percentile. Now that's very good and useful on multiple choice. But if it's open-ended, you want to show some math. You want to be able to demonstrate some content knowledge. So it's actually better if it's open-ended to find the z-score and then plug it in and use the algebra to find the value. It's better as holistic credit. It's not as valuable to use the calculator to just spit out the answer in that instance. Okay, so that uses inverse norm in 2 different ways. It also finds us our answer fairly quickly. What I want you to do now is the attached worksheet. It's 2.2a, and it runs through the material that we've covered thus far in 2.2. Okay? That is, of course, due tomorrow by 7 a.m. Also, as I'm sure you know, we are returning to school tomorrow for the usual, at this point, hybrid model. So students A through L will be in school tomorrow, and through Z will be distance learning. I will have the Google Meet enabled during the class period. If you want to log in, you're welcome to, for tomorrow and days forward. All right. Again, for today, I'm not going to be able to make the Google Meet, and I'll post that in the announcement as well. Have a great day. If you have any questions, let me know.